Okay, so that paper from Arrow, we will discuss it a bit later when we do the externality thing. It's a famous paper because in some sense it's a paper that introduced the old literature about asymmetric information and the use of information in economics. It was elaborated in other thing, but so, you know, the lemon story that gave Akerlof the Nobel Prize, as you know, as Arrow pointed out once at dinner, was a homework, take-home homework he gave, and he thought Akerlof's paper was nicer than other. He said, why don't you continue and, you know, make it a full paper, and so on. Same for the signaling part. Anyhow, so he followed coherently this idea of trying to characterize information in general and knowledge in general as ideas. And if you read the paper, you see he touches upon different things. At a certain point, he gets to the matter. I'm not going to go into the insurance, financial, because that's not what the topic of the class, okay? And I think his insights there were a lot stronger and empirically correct, and in fact are still standing and are pretty much the basis of that. He wants to apply that thing also to the analysis of innovation, technological innovation, R&D. And his position there, I'm afraid, is somewhat contradictory, because he wants to have, with an American expression, his cake and eat it too, which means in Italian it is the moglie ubriaca and the botte piena, or as my mother, who was the daughter of a horse trader, said, el muso, which was the donkey, è 60 franchi. That is, you want to sell the donkey and keep it as well. And Arrow is doing a bit that. So what he wants to have is an argument that says there cannot be good production of innovation idea under competitive equilibrium because of this immaterial, non-excludable nature of ideas and innovation, and the fact that they are non-rigorous, okay, as opposed to coffee. And this is going to be a topic I'm going to treat with you a lot later when we discuss externalities. But at the same time, he doesn't like monopoly either. He doesn't like patents either. Can never like patent. So he always thought that patents, following somewhat logically from his argument as the lesser of two devils, you know, as a second best, you know, meglio peggio, to use an Italian frequent expression, okay? He didn't like it. So he went to a long way to try to argue that also monopolists are not good, because what he wanted, and on this he was a very strong advocate, he was a big advocate of public financing, of public support for research. But if you read that paper, you realize that there is a part at the end in which suddenly he starts talking about NSF and stuff like that, and you go, Jesus, I don't know, what is, you were writing an editorial for the Wall Street Journal and ended up in the file for the academic paper or something. And so this is something I discussed with him. I was very lucky to have spent many summers with Arrow at the Santa Fe Institute, first in Stanford, and then at the Santa Fe Institute between 85 and 94, and I learned quite a bit of that man. I was a fantastic man. And so he was a big advocate of public financing of research. And so he has this result, to get to your question, in which he wants to prove that a monopolist is not really good at innovating. The monopolist does not have any innovation at innovating. Which I tend to agree, but for completely different reasons. And his intuition is that the monopolist does not innovate because it will replace itself. Right? So the monopolist is already making profits. That's Arrow's argument. Intuitively, you can check the details in the paper, but there are various ways of proving it.
Yeah.
But you can write your own model in which that's true. As you are a monopolist.
Reuse it.
Yeah, Agiona would use it, and in fact, that argument, unfortunately, is subject to a lot of if. We will get to that. His argument is, you're already making profits. And because if you're making profits, the additional profits that you will make by improving upon, say, your cost function, so you reduce your cost 10%, will only gain you that extra 10%, and therefore your payoff will be lower than the one of the challenger, than the competitor, then you innovate less. Right? That's the argument that Arrow has. In my opinion, it's a fine argument, but it depends. It's a classical word in which a lot of things depends, and in looking at young Howitt in the second part of the lecture today, we will do that. Okay? But that's the argument. That's what's considered the Arrow replacement argument. Okay? That's what they refer to. More on the technical thing. All right. So let's start then from the question you had and connect it to the work with Aldo, and then we'll go to external. Let's look purely at the technical thing, right? I'll do everything in discrete time because it's simpler algebraically, and you don't have to use funny symbols, but it works pretty well, pretty much also in continuous time if you care, but it's not really anything you gain, and the math becomes a bit more cumbersome. So let's re-look at the way in which Romer and then many other introduce external effects in this production function at the time. Okay? We will discuss later what is the meaning of this external effect. What is that I'm looking at outside there in trying to measure them. And discuss a little bit. There was for a period very broad literature on that in my opinion, and I think in the opinion also of those who carried it out, went nowhere. That is, found no trace of these externalities. But for 20 years, this was the big thing. So what's the idea? The idea, if you're Italian or if you're from Silicon Valley, is the idea of the distretti. Okay? So the idea is that I am a firm I. I have a production function, I have my own stock of capital. Okay? And a bunch of other inputs. Okay? But I'm surrounded or I'm in touch with other firms. And they also have their own stock of capital. This stock of capital, to the extent, and here is the first approximation, people talk about stock of capital, which is that thing we measure in terms of plants and machines and things like that, but actually what they have in mind is some kind of accumulated knowledge, okay? Technical knowledge how to do things, and the idea is I use that as a proxy for the stock of capital. Pretty terrible way of doing it, because if you look at that, the stock of capital of a steel company as measured by national income accounts is a lot bigger than the stock of capital of Google. But then, Google has a lot more knowledge. In fact, in recent year, one should say, in the United States, and I think they're starting to do it also in Europe, the national income and product account have started to update the measurement of capital stock by adding some measure of knowledge. This would be deserving of a lecture by itself, but will take me off. If you're interested, there is a very nice paper by Raul Santaeulalia Llopis and Sang Yu. Raul was an assistant professor at my place. We unfortunately could not keep him and tenure him, but he's now in Barcelona, the Autonoma, and Sang Yu is Queen's Mary, London. She's a student of mine. I think it's coming out in JPE, but if you look in the internet, you'll find it, and if you don't find, ask me, I'll send you a copy. And the paper shows a remarkable result that, at least as far as the United States is concerned, if you redo the national income and product account by taking into account the fact that now they started in 1999 and it completed in 2013. The stock of capital also includes all R&D, all expenditure in software, all expenditure in marketing, brand build-up, and so on. And before, we were treated as intermediate expenditure. Now they're treated as investment. And so they're both part of net output, right? So output has increased because of that, value added, okay? And they also are posted to accrue completely to capital as income, which is not obvious at all. Not obvious at all that they should accrue to capital, right? Not only, these items have a much higher depreciation rate, than physical capital. To give you an example, structure depreciates at 2-3% a year. Your computer depreciates at 30% a year, and your software depreciates even faster because it gets obsolete very quickly. So obviously when you add a huge chunk of capital to capital, and that chunk of capital depreciate faster, remember it's gross domestic product, gross national product, right? That includes depreciation. Depreciation goes up. In fact, you look at the time series of depreciation of capital, it used to be around 5-6% in the 50s, 60s, and 70s, and you can look in the late 70s, early 80s, start moving up, and it's now traveling around 9%, okay? That increases the share of income going to capital by accounting. So the thing that Raul and you show is that in fact the pure accounting change explains pretty much the old decreasing labor share in the aggregate. Not sector by sector, so there is the interesting thing, in fact, it's work I'm trying to do with another student. In my opinion, the interesting thing is that in some sector, manufacturing in particular, labor share has decreased for real, that is independently of accounting. In the aggregate, the effort is not that visible when you do things right, because in other sectors, finance, for example, or services, the labor share has actually increased. Okay? And so once you do things properly, there is really not a big change in the aggregate. But that doesn't matter. In fact, if you want to understand some of the economic mechanism at play, you'll have to look at sectors. And in some sectors, yes, it has decreased dramatically. Manufacturing and transportation in particular. Okay, so that's an aside on the use that this early literature made. The early literature just treat the physical stock of capital as a proxy of knowledge. Okay, and says these have some positive external effect on that. In other words, if that firm over there increased their capital, my productivity of labor increases, my production function shifts up. Okay. We'll discuss the reality of this later. Let's just stick to the mathematics, okay? So we summarize this by writing a production function with 3 arguments. My own capital, I'll take away time t, okay? All the other factors and aggregate capital, okay? And the derivative with respect to the 3 are positive. And there is some implicit assumption that in fact d second f in dki dk is also positive, and the same for the other inputs. So if the other people increase their capital stock, the productivity, not just the level, but the productivity of my own investment and my own factors of production go up. That's what we call a positive externality. Again, let's stick to the technical aspect of it. What's the technical aspect? Remember, the technical aspect is, in order to study the dynamics of the model, first you simplify and put all other factors equal to 1, okay? So it becomes a constant. So this remains the only choice variable for the firm, okay? There are a bunch of individual firms, each one has to solve a programming problem. Then we make a bunch of other simplified assumptions, and one assumption is a firm and an individual and a consumer are the same thing. So in fact, the economy that is being studied with a lot of simplification, in my opinion, but anyhow, by that literature, is a strange economy in which we're all identical, each one runs a farm, I eat my own stuff, I have my own capital and my own labor, we pretty much do not trade, but your cows and my cows have external effects. It would be better if it were the old story of the orchard and the bees. because I guess your cows and my cows probably have negative external effects, because where your cows go, my cows cannot go. If your cows eat the grass, my cows cannot eat the grass. If my cows shit on the river, your cows cannot shit on the river, and so on and so forth, okay? But hey, whatever, okay? So your plant and my plant exchange information, and they both become more productive. That's the word that is being described. A word like that is easy to analyze mathematically because it becomes a word in which I'll take away the letter I everywhere but in K, and then I take it away there too, because otherwise it's just too much notation. You know, each individual maximize the usual discounted utility of their own consumption, subject to the constraint, and again I use the simplification the other day that the production function includes also depreciation, okay? That this is equal to this and the external effect, okay? Now then is, what did you say? You say given KT, so what's KT from the point of view of a programming person? It's a sequence. They look at a sequence of capital stock in the economy and treat it parametrically. Right? They guess right the aggregate sequence. Mathematically, that's what's being done. Right? The assumption is each individual take an infinite sequence of capital stock as given. It's like a set of parameters. And given that sequence, you put one element of it in each one of the production function in each period, okay? They choose their own, all right? So when you write it in a very abstract sense, this is a very complicated problem. Because even if given the sequence, this is a concave problem, so you assume that f is concave in this variable, okay? So you can treat it like an alpha, beta, gamma, right? Remember, at that point, parametrically on that, this is just the standard problem. The only difference is that the form of the shape of the production function is changing over time. But because it's changing over time, due only to this change in the value of the sequence, it's a lot more controllable mathematically, okay? It's not some generic function that changes, it's going to be that, right? So basically what these guys are doing, if they take that sequence parametrically, their problem satisfies the condition we mentioned the other day of Mangasarian, right? From the point of view of the single agent, an optimal sequence parametrically on the aggregate sequence is a sequence that satisfies the Euler equation and the transversality condition. Notice that here the transversality condition is not trivial, because the sequences we're studying are by assumption unbounded. So in the standard problem we mentioned last week, transversality condition was always true because the sequences were by definition bounded. Here they should be checked. That's where in this literature people screws up so often. But if you look at the stuff we do with Aldo, we go very carefully with the transversality condition. Other authors, including the one I recommended you to read, don't. But that's their problem, okay? Here you have to check the transversality condition, okay? Because it's not obviously true. And that's why it's useful, because it allows you to impose restrictions on the utility and production function. Anyhow, given that, you basically studying this. Right? That's the marginal utility of the consumption of household I given the aggregate choice, and this has to be equal to the marginal utility again of household I next period Okay, so notice here the notation becomes a bit more complicated, right? So that's my output today as a function of my capital stock and the stock of the other people. It's my choice of investment and capital. It doesn't depend on it. As tomorrow, margin material consumption for me, that's my output tomorrow, which depends on my choice and the other people's choice. Okay? That's my choice of stock capital for yet another period. That's why I put F1 here. That's the derivative with respect to the first variable, the first argument. Because that's my marginal productivity of capital, of my capital, given the capital that the other people have purchased, given the externality, okay? So you see, it's a kind of an Euler equation, but it's not really an Euler equation, okay? What's the next thing that these people do? They say, well, they're all identical, and they have perfect foresight.